All right, good morning, everyone. Hey, Jacob, identities. All right, so welcome to the last 4 weeks of class. So we still have 4 weeks. In this 4 weeks, what we're going to be doing, we still have 2 sections to deal with sine and cosine, which will be done hopefully this week. And then next week, we are going to study conic section. Okay, what's conic section? It means what's the equation of a circle? Sorry, what's the equation of an ellipse and a hyperbola? So that's what we call conic section. And then we will study a little bit of something called parametric curve. Okay, I will not explain it now. I will explain it next week. And the last day of class or the day before it, we will do something very simple: how to solve a system of 2 equations, which is usually fairly simple for the class. So today and on Wednesday, we're gonna finish the trigonometry part, and we're gonna study what's called trigonometric identities, which is the relationship between the cosine and the sine, the secant and the tangent,
Oh my God.
so on and so forth. Okay. Now, I didn't have the chance to look at your exam yet. It was, the reason is my other classes have exams, so I have to work on them in terms of giving them review and stuff like that. So that took all my weekend. All right, so trigonometric identities. The first notation. Notation is important here. I think I talked about that once before, but I want to make sure I understand it. When is the last day of class? Oh, that's a good question. I think it's April. For you, I think, don't take me for sure, I think it's April 28th, because we still have 4 more weeks. So if my memory is right, it's April 28th. Okay, that's a notation. There is this notation in math that I know that I talked about, but I want to make sure it's fairly clear. Cosine square x, cosine square t. This means the cosine t to the power 2. So crucial to understand this notation. The same goes for cosine cube of t is the cosine of t to the power 3. Okay, so instead of writing cosine 3 to the power 3, people put cosine cube right there. And it's the same goes for sine, for cosine, for tangent, for cotangent, and so on and so forth. The first trig identity we're going to talk about is the relationship between the sine and cosine. So it's called Pythagorean identity, one of the most important identity in trigonometry. Now, yes, the last week, and then I go back, it's the final exam week. So classes will end April 28th. And the week up to 8th, the last week is final exam. That's how it works. So Pythagorean theorem. Okay. Pythagorean theorem goes like this. It built a relation between the cosine and the sine. So what's really happening between them? Right. Sine and cosine is basically, the definition of them is the unit circle definition. That's really what the sine and cosine is. And if I take any angle, no matter what it is, you can call it theta, you can call it t, you can call it anything you want. The sine is, the cosine is the x coordinate, and this is the sine. Okay. And that's the unit circle. So the Pythagorean theorem tells me, so I'm looking at this triangle, tell me that this square, it means the cosine of t square, plus this side from here to here, this is the cosine, that's the sine of t square, Pythagorean theorem, equal to 1 because I'm working on the unit circle. Okay, so Pythagorean theorem is the first theorem which relate the sine and the cosine. Very important trigonometric identity. So this reads that cosine of t squared plus sine of t squared equal to 1. Now, you will rarely see it written this way. Usually people use this notation. So it means that no matter what the angle is, cosine square plus sine square of an angle equal to 1. So what does this identity mean to us? This means the following, that no matter what t is, it doesn't matter what angle you use, if you compute the cosine of the angle squared plus the sine squared, you get 1. So identity means that this equality holds regardless what the angle is. Now from this identity, we can deduce two nice properties. So this is going to tell me that if I solve for the cosine, so this tells me that the cosine square, so I'm going to solve for it in terms of sine, is 1 minus sine square. Okay, so I'm solving for cosine in terms of sine. And or I can say from this, the sine is 1 minus the cosine square. Okay, so the first most basic, most important trigonometric identity you will ever encounter is this one. All right, so let us practice it a little bit. I'm going to practice it in the following sense. I'm going to give you angle where you know the sine. I'm going to ask you to find the cosine of the angle using those identities. So we can practice them a little bit. So example number 1. So this is you have to kind of drill it in your head. It's always so important. So let me practice it a little bit. So application. Example number 1. So suppose I tell you the following. You're given sine of t equal 1/4. You're given the sine. And you're told that t is in the first quadrant. So you're given this information. Okay. The question is, find cosine of t, tangent t, and I want this to be done without evaluating the angle. Evaluating t. Okay, so I'm giving you the sine. My question is, I want you to find the cosine, the exact value of the cosine, without finding t. What do I mean? I mean that if sine t is 1/4, I can use the arc sine to find t, but I don't want you to do that. So I don't want you to evaluate t. I want you to use those identities to find the cosine. All right? Are you with me? Okay, so let's see how can I do it. Okay, I say the following. I know the sine. I want the cosine. So I'm going to use this trig identity. You can either use this one, or if you only memorize this, you will be okay. So, okay, we know the following. That cosine square t plus the sine square equal to 1. That's what we know. Right, so I want the cosine. So this gives me that the cosine square is 1 minus the sine square. Okay. Exactly. So cosine square is what? Is 1 minus sine square of t. It's given. So that's what we have. Sine of t, and Kishan is right, is 1/4. So this is minus 1/4 squared. Okay. And so this will give me the cosine square equal. Now we have to do the math. 1/4 square is 1/4 times 1/4. That's 1/4 square. So 1/4 times 1/4 is 1/16. And the question is, we want to do this exactly. So I don't want decimals. I just really want you to be able to do the algebra correctly. So this will give me the cosine squared equal. So I don't want decimal, so I don't want any calculator use. 1 minus 1 over 16. If you want to simplify this, I need to find the common denominator. So it's going to give me 16 over 16 minus 1 over 16. Okay, so it means the cosine square equal 15 over 16. All right, now I need the cosine. So what's the cosine now? Back to you. What's the cosine? I know the cosine square. What's the cosine? I'm listening. How can I get the cosine from the cosine square? Kishan, since you started it, get me going.
Would you square the top and the bottom?
No, we don't square. Be careful. What do we do? Not squaring. Cosine t squared is that. So cosine t, what should we do? Take the square root. Right? We don't square, we take the square root. It means the cosine t is the square root of 15 over 16. Okay? So it's not, we don't take the square, we have to take the square root. Now, this is, I have to address this issue. And I want you to listen to me. On the side, it's not related to this problem a little bit. Suppose I tell you x squared equal to 4. And you solve for x. What do you get for x? Okay, so note on the side. Suppose I tell you solve x squared equal to 4. What is x? Please quickly put it on chat or exactly. Anybody else? It's not only 2. It's not only 2. It's 2 or minus 2. Is that correct? So sometimes you write it plus or minus 2. Why? Because if you plug in 2 for x, you get 4. If you plug in minus 2 for x, you also get 4, because if you take minus 2 and square it, it's minus 2 times minus 2, which is equal to 4. So if x squared equal to 4, it means x could be either the positive 2 or the negative 2. So if I go back here, if the cosine square is 15 over 16, it means the cosine of t could be the positive of that, or cosine of t could be the negative. In other words, cosine of t, there are two that are either the positive square root or the negative. Okay? But now, and we're almost done. But now, which value we need to pick up? Is it the positive or the negative? Now let us go back here. I'm telling you, the sine is 1/4 and t is between 0 and pi over 2. So, but here we know that. So that's what's given. But we're given t between 0 and pi over 2. Okay, so this is my unit circle. The cosine is 1/4. So this is 1/4. That's the cosine. And the angle is in the first quadrant. It means the sine, so it means that the cosine of t is positive. So this tells me that the cosine of t, so there are two values, because if the sine is 1/4, okay, this is the angle. It could be positive or the angle could be here. So both angles have the same sign. So the cosine could be either positive or negative, but the problem tells me that the angle is in the first quadrant. It means the cosine is positive. So the cosine of t, it will be the square root of 15 over 16. Now I don't want you to use the calculator. So this is equal to what? Now the square root of this over that, we can break it into over the square root of 16. It means the square root of 15 divided by 4. Okay, and this will be the cosine. Right? Now it looks like a lot of work. It's actually not. I'm just doing it in a lot with a lot of details. All right, so I know the sine. If I know the sine, I can find the cosine without having to go through the angle. And I can find its exact value. And that's really the important part here. I'm really finding the exact value of the cosine. Please ask questions as I move on. Okay, now I want the tangent. The tangent is a tangent. It's the sine over the cosine. Now we do that. So what is the sine here? The sine is 1 over 4. The cosine is the square root of 15 over 4. Now I use the properties of fraction. So that's 1 over 4 times the reciprocal of that. 4 and 4, 1 over the square root of 15. And that will give me the tangent. Okay, now if I want the secant, the cosecant, I can find all of them. So let us summarize. Yes, question. Yes, Kishan.
I thought you can't have a radical in the denominator.
Oh, yes. Yes. Whoever told you that is not right. Yeah, you can. You can. I know what you mean. In high school, they teach you that you can have a radical in the denominator. This is a number, right? If you take your calculator and you evaluate the square root of 15, what do you get? You get a number. You get 3.87. There is no problem of having a number. The only thing you cannot have in the denominator is 0. Anything else, no problem with it. Is that clear? As long as it's a number, I don't care. So this is absolutely correct. So let us summarize a little bit here. How did we use the identity? So the idea is that I know the sine, I want the cosine and then an exact value. I don't want to go through the angle. So I said, okay, if I know the sine, I can find the cosine very easily. It's 1 minus the sine. Once I use this identity, I plug in the value of the sine in the expression, and then I solve for the cosine. Yeah, it's no. I don't worry about that. You can have square root in the denominator. That's the end of that. It is proper. It's fine. It's a number. It's a non-zero number. You're safe. Okay, so do not worry about those details. All right. So another example, and I'll give you a few minutes to do it, and then we proceed. So you're given. So you're given the following. Cosine of t, so I'm giving to the cosine, equal 1/3. So the cosine is positive, but the angle is between 3 pi over 2 and 2 pi. Okay, the question is find sine of t. Okay, so I'm giving to the cosine, I want you to find the sine without finding the angle, just by using the identity. So you guys have 2 minutes to do it, get going, and then put your answers for me. And I usually do them with you. No decimals. I want everything expressed as fractions. No decimals at all in those problems. Anybody? Any answers? Okay, kind of. Anybody else? Okay, all right. So I'm gonna go. Everybody have correct up to something. Everybody have a small mistake. Let us see. I address the mistake before I do the math. Find the sine of t. Listen carefully. The cosine is 1/3. So the cosine is 1/3. The angle is between 3 pi over 2 and 2 pi. So if this is the cosine and the angle is between here and here, it means that's my angle. And that's the angle here. So my angle is in the fourth quadrant. So now t, so let us note before I do, t is between 3 pi over 2 and 2 pi. It means t in quadrant 4. So the sine of t has to be negative. Okay, so we're going to start with that just to say where the angle is. So the sine will have to be negative because it's a y coordinate. Now we're going to find it. Now let us find the sine. Let us find the sine. Now I do what you guys have done. Okay, we know that the sine square plus the cosine square is equal to 1. I always start with this because this one I memorize. I know the cosine, I need the sine. So I'm going to solve for the sine. Means sine squared t is 1 minus the cosine square. It means sine square equal 1 minus 1 over 3 to the power 2. Means this is equal to 1 minus 1 over 3 times 1 over 3. You multiply the denominator 1 over 9. So now common denominator. It means 9 over 9 minus 1 over 9. It means 8 over 9. So now I have that sine square of t, which is, I keep writing it, which is sine t square is 8 over 9. So now it means that the sine could be two values. Either the positive square root or the negative square root. So there are two possibilities for the sine. But now I know, but the sine of t is negative. Since t is between 3 pi over 2 and 2 pi. So this gives me the sine is equal to minus the square root of 8 over 3, which is, we can write it like this. The square root of 8 is 2 root 2 divided by 3. End of the problem. All right, so why did I pick a negative, not the positive? Why did I pick negative, not positive? Do you guys understand? Yes, Kishan, what's your question? Kishan? Okay, so why did I pick the negative? Because the cosine is 1/3, but we know that there are two angles that have the same cosine. There is this one, and there is the big one up to here. But because they are telling me t between 0 and pi over 3, it means they are looking for the angle in the fourth quadrant. Since this is the angle, my sine will have to be a negative number. So now when I find the value of the sine, I pick the negative number. All right, questions before we proceed to other identities?
Yeah, where did you get the denominator 3 from?
Oh, good question. All right. Let me do it on this side. You get this part, right? This part, you get that, right?
Yes.
Okay. Now, the square root have the following properties that from algebraic property, that if you are dividing, you can split the square root. Okay, what does this mean? It means I can split this into the square root of 8 over the square root of 9. Are you with me so far?
Yeah.
Okay, very good. Now, what's the square root of 9?
3.
Exactly. That's my 3. Okay?
How come you wouldn't solve the square root for 8 then?
Okay, square root, because there is no, can you think of an integer? When you take it to the power 2, it gives you 8.
4?
4 squared is 16.
No. Yeah, I realize that. So then
Right.
it
Okay.
would have to stay.
Exactly. But 3 square root of 9 is easy. It's going to give you 3. All right. The best you can do with the square root of 8 is the following, which is, where did I get 2 root 2? Square root of 8 is 4 times 2. Am I right? I think. Okay. Now, square root of 4, again, one of the properties of the square root is that if you are multiplying, you can split. If you have multiplication, then this will end up having the square root of 4 times the square root of 3 over 3. It means 2, and there is a minus, of course, root 2 over 3. And I'm going to stop right there, because the square root of 2, there is no number, not no number, of course. There is no integers that when you take to the power 2, it gives you 2, so it's going to stay.
Okay,
So
thank you.
Sure.
if I were to leave it as square root of the negative 8 over 3, would that be wrong if I
No,
didn't?
absolutely not wrong. Absolutely not wrong. Okay, no, it's correct. Yes.
Okay, thank you.
But it's just the idea is that, you know, you guys have to learn a little bit how to simplify. And I know a lot of you do. Okay, that's the idea. Okay, any other question? All right, so this takes care of, I mean, of course, you guys are going to have problems to work yourself. This takes care of the relationship between the sine and cosine. So that's the first trig identity we have. So very important, as I say, means no matter what the angle is, you take the sine square plus the cosine square, you're going to get equal to 1. Now, the other identity we are going to build is the relationship between secant and tangent. The same way sine and cosine are related, the secant and tangent are related. And what's the relationship between them? So the relation between secant, the secant of an angle, I remind you that the secant is 1 over cosine, and the tangent, which is the sine over cosine. Just like to remind you those always.
There's some questions in the chat.
Oh, yes, Kishan. I'm sorry. Would you take point if we have radical 8? I said no. I said no. I will not take point if you have the radical 8. All right? No, I will not. Any other questions? Sorry, I didn't see it because I thought okay. Very good. Now, the relation between secant, which is 1 over cosine, and the tangent. It means what's the identity that relate them. So first, I will give you the identity, and then I will explain a little bit where it comes from, because the identity is the following. The secant square, remember, secant square is exactly secant to the power 2, is 1 plus the tangent square. This is the most used one, and this one also used, but that's really the basic one. This also is used. Believe me, I'm using it in calculus 2 now, a lot. So secant square is 1 plus tangent square. And okay, where it comes from. I will explain why this is true. I mean, why this mess here. All right. There are 2 ways of doing it. I'm going to do it the following way. Okay, let's see why. Suppose I take 1 plus tangent square. And I'm going to tell you why this gives me secant square. So follow me the best you can. All right, it's 1 plus. What's tangent? Tangent is sine over the cosine to the power 2. Am I correct? Am I fine? Tell me yes or no. It's 1 plus. Now, sine t over cosine t squared, it means sine t over cosine t, you multiply it by itself. So you end up with sine of t squared over the cosine of t squared. Okay. So this is going to be equal to 1 plus. Sine of t squared is sine squared t over the cosine square of t. So I'm going to show you that if I take 1 plus tangent, I'm going to get the secant square. Very good. Now, I'm going to do something. I'm going to find a common denominator. Common denominator. Okay. What's the common denominator here? Back to you. What's a common denominator? Don't be afraid of your answer.
1.
No. Why 1? If I tell you 1 plus 1 over 9, what will be your common denominator? When you add those, what's the common denominator?
10.
No. It's 9. Why 10? The common, okay, let me take some simple. If you have a half plus a third, what's the common denominator here? How do you remember how you do it? It means what is this number that is a multiple of 2 and a multiple of 3? Okay? Multiple of 2 and a multiple of 3, 6. So if you want to find a common denominator, you have to multiply this by 3. And you have to multiply this by 2. And that's what you get a common denominator of 6. Okay. 1 plus 1 over 9. What's the common denominator? What's the number that's a multiple of 9 and 1? 9. And if you find a common denominator here, you get 9 over 9 plus 1 over 9, which will give you 10 over 9. Okay. All right. Okay, so let's go back here. What's the common denominator here? If this is cosine square, what will be the common denominator? Yes, Kishan, we will cover a lot. What's the common denominator? The common denominator is going to be cosine square of t. So let's see how we're going to do that. 1, I'm going to multiply this by cosine square, divide by cosine square. So I'm not changing anything. Plus the sine square over cosine square. So as I realized, I didn't really change anything. I just find the common denominator. Now I'm going to combine. Now, why do we find a common denominator? We find a common denominator so we can combine numerators. So this is going to be equal to cosine square. I'm combining the numerator now over the cosine square. And now what do we get? Cosine square plus sine square, that's the famous Pythagorean, over the cosine square of t. But now I'm telling you this is equal to what? This is 1 over the cosine of t square, which is 1 over that squared, which is secant square. That's secant to the power 2. It means secant squared t. All right, so let me a little bit repeat what I did. I took 1 plus tangent square, and I substituted tangent by its value in terms of sine and cosine. So I get this square. Now sine t over cosine t square, it's the numerator square over denominator square. So I ended up with this. At this stage, I said, I need to find a common denominator. So the common denominator here, because this is 1, and this is, so the common denominator is cosine square. So how do we find a common denominator? I multiply by cosine square, I divided by cosine square. So I haven't changed anything, plus this piece. Now, the reason we find a common denominator is to be able to combine the numerators. And that's what I did. I combined the numerators. Now, Pythagorean theorem, that's really what I use it. That's why it's the heart of it, tells me the following. That's Pythagorean. Tells me that cosine square plus sine square is always 1. I divided by cosine square. And now this is secant square. Why is this secant square? Because this is 1 over the cosine of t, which is 1 over cosine t square. Those are the same, because if I take this multiplied by itself, that's the secant square of t. Okay, so the relationship that relate the sine, and the secant and the tangent is that secant square of t is 1 plus the tangent square of t. That's how tangent and secant are related. So we have two basic identities, the one relating the sine and cosine, and the one relating the secant and the tangent. So let us practice this a little bit. So for example, you're given the following. You're given, let us say, tangent t equal to 3, and t is in the first quadrant. Okay, find secant of t. Okay, so you're given tangent, t between this and this, find the secant. All right, how can I find the secant? Well, so the idea is I have to use my identities. I know the tangent, I want the secant. So find secant and cosine. I'm gonna find both of them. All right, so if I know the tangent, how can I find the secant? I say, okay, we know the following. Two things. First, let us note that t is in between 0 and pi over 2. It means the secant t, is it positive or negative? Back to you. Is the secant positive or negative? Positive justify, negative justify. Positive? Rebecca, positive? Absolutely. If the angle is here in the first quadrant, everything is positive, actually. But the secant is 1 over the cosine. The cosine is positive, it means this is positive. So it's nice to start deciding what is positive or negative. Now we need to find it. I know the tangent, I need the secant. So let us see. We know that the secant square is 1 plus tangent square. It means it's equal to, we know the tangent, 1 plus 3 squared. This is equal 1 plus 9 equal to 10. So the secant square, which is this squared, equal to 10. It means secant t is, as I say, square root of 10 or minus the square root of 10. There are two values that satisfy the property that their square equal to 10. But secant t is positive. It means that the secant is the square root of 10. So if I know the tangent, I can find the secant using these identities. Okay. Now, what's the cosine? The cosine is 1 over the secant. So the cosine is 1 over the square root of 10. You can keep it 1 over the square root of 10. There is no problem or whatsoever with that. All right. So far, two identities, very basic. These are the most important identity, and it will be great if you can at least memorize this one. Really, really memorize it. So now, before I move further, we're gonna do something called true or false. Can I move on? All right. When we say it is an identity, when I tell you this is an identity, what does the word identity mean? Identity means that no matter which value you put in here for t, this holds. It's a formula, no matter, it's a rule. It means if I put in here pi over 3, I'm gonna get 1. Pi over 4, you're gonna get 1. Regardless what you put, we're gonna get 1. So now I'm gonna give you something called true or false, very important ones. And my question would be, I mean, it is on bright space, but I will try to do true or false. If true, justify. If false, give an example to show it's false. So I'm going to do a bunch of stuff and I'm going to write them clearly because I know this is not very clear, but this activity is on bright space. So the first one, true or false, means, what does it mean true? It means, can you plug in any value of A and B? Will this hold always? Yes or not? Okay. What do you think? True or false? If true, you tell me why it's true.
True.
If false, you give me an example. So basically, can I split the square root? Okay, I'm getting yes, yes, yes. Everybody agree? Yes, oh my goodness. Anybody want to say no? Absolutely false. All right. It means if you have a sum, and we're going to, I'll give you an example what. If you have a sum under the square root, you cannot split the square root. Okay. If you have a sum, we cannot split the square root. It's false. Now, false, I want an example. Who can give me example? What do I mean by example? Who can give me a value of A and a value of B so that this equality fail? That's what it means. Give me an example. So this is absolutely false. We cannot break the square root. 9 and 4. All right. That's a good example. Can you give me one even easier? So let me take A to be 9. I'm going to take one. It's a bit easier than the one your classmate gave me, even though the one she gave me is actually perfect. But to make the math even easier, I'm going to take A9 and B16. And now let's watch carefully. If I take A plus B, I get 9 plus 16. It means square root of 25. It's equal to 5. However, if we break it, we get the square root of 9 plus the square root of 16, which is 3. And square root of 16 is a 4, which is equal to 7, absolutely different from each other. So we cannot break the square root. Absolutely false. Be very, very careful. It's a fairly common mistake. So I know that it has nothing. Yeah, one would be whatever numbers you want. I don't really care. As long as you convince me it is false. So false, it means you have to give me examples to convince me it is false. So I started with the simple one because then I'm going to move to trigonometric identities and properties. Okay. All right. B is true or false. So is the cosine, so I'm going to write it big. Cosine minus t means you take an angle minus t. Is this equal to the cosine of t? True, it means always true. False means you give me one example to convince me it is false. So do you think this is true or false? The only hint I can give you, think of unit circle. That's really the definition of circle. What do you think? True or false? Means if you take any angle, you find its cosine. You take minus it, you find the cosine. Do you get the same value, regardless what t is? So true, it means always true. Okay. Right, and now Erin is fixing her mistake. So this is my unit circle. Okay, now Anybody else? I want answers on chat. True or false? What do you think? True, it means always true. False, you give me one example to convince me it's false. Anybody beside Aaron? False, okay. If you tell me false, you give me an example. What's your example? You cannot just tell me false. You give me an example. It means you give me a particular value of t such that this fail. Okay, 180. I'll play the game with you. 180. What's the cosine of minus 180? Okay, your classmate is giving me 180. What's the cosine of minus 180? Now let us remember, what is minus 180? Start from here. You go back here. So what's the cosine of minus 180? Please, very quick, because we have a lot to talk about. What's the cosine of minus 180? Minus 1. Very good. What's the cosine of 80? 1. No. What's the cosine of 180? It's not 1. It's minus 1. Because this is 180, you go around the circle. That's 180. What's the x-coordinate here? No, the cosine is the x-coordinate. What's the x-coordinate here? Minus 1, 0. So cosine minus 180 is minus 1. Cosine 180 is minus 1. The example your classmate gave me is not working. Okay. Anybody have another example? If you want to tell me false, you have to give me an example. So minus 180, the cosine is the x-coordinate, is minus 1. Plus 180. Okay, so it's absolutely true. And let's see why. True. So this is absolutely true statement. And let's see why it is true. And as your classmate pointed out, we're going to use the symmetry of the unit circle. If this is t, the cosine is the x-coordinate. That's the cosine. What is minus t? This is minus t. And what can we say about, so this is the point Q. So we can write, so cosine t, using the picture, is the x-coordinate of the point P. The cosine of minus t is the x-coordinate of the point Q. So by symmetry, P and Q have the same x-coordinate. So the cosine of t and the cosine of minus t, that's an identity. They are always equal to one another, regardless what the angle is. So cosine pi over 4, cosine minus pi over 4 are the same. Cosine pi over 3 minus pi over 3 are the same. Okay, so that's an absolutely true statement. All right. So we keep working along the same line. Suppose I take, so which one my question now? Sorry. Okay, here we are. Suppose I take sine of minus t and sine of t. True or false? True, justify, false. Give me an example to convince me it's false. Again, because you're working with sine and cosine, think about the unit circle. Okay, true, justify. So it's my unit circle. Okay. Remember the definition of sine. Remember the definition of sine. Suppose this is my angle T. right? Let's say pi over 3, for example. What's the sign? That's the sign of t. Okay, take t pi over 3. What is minus t? That's minus t. What is the sign of minus t? Okay, I am done. True or false? Back to you. Absolutely false. So now give me an example. Who can give me an example? Because the picture tells you the sign of t, if t is in the first quadrant, the sign is positive. The minus is going to be in this quadrant. That's the only angle that failed. This is not a good example. Let me see why. Aaron gave me an example. That's the only example that's really not working, and tell you why. Suppose t is 180. Why her example is not a good one? Yeah, because if I take t 180, what's the sign of minus 180? I go back to my unit circle. This is 180. That's minus 180. What's the sign of 0? What's the sign of 180? Is 0. So unfortunately, this particular example doesn't work. But for this to be true, it has to be true for all angles. So if you give me one angle for which it is true, which is very interesting, it doesn't mean it's true all the time. It could be true for one, but identity means it's always true. So who can give me another example? Who can give me another example? I saw something. Suppose I take t to be 90 degrees. Then what is the sign of minus 90? And what's the sign of 90? Okay, what's the sign of minus 90? If you start here, you go down, that's minus 90. So the sign is minus 1. The sign of 90, that's 90, historical, which equal to. So it's absolutely a false statement. The sign of minus t is not the sign of t. So now, actually, I'm going to give you the rest, big part of it for you to practice. So let me ask you the following question, which is F in the worksheet. That's going to be assigned for as a homework for next time on the top of your homework. F in my worksheet. What do you think is the correct relationship between those two? What do you think is the correct relationship? So they are not equal. That's false. Can anybody tell me the exact identity between them? Again, using the unit circle as a guideline. You can give me the correct relationship between the sign of t and the sign of minus t. You can give me an identity, thing that relate both of them. So if you compute sine of minus pi over 3, sine pi over 3, what do you think the relationship between them? Sine minus pi over 4, sine pi over 4. What do you think is happening? Okay, so let me rephrase the question. True or false? True or false? Okay, is the sign of minus t equal minus the sign of t? What do you think? Look at the unit circle. True? Anybody? What do you guys think? Is she right? Let's look at the unit circle. If this is the angle t, I'm going to call this is p. This is minus t. I'm going to call this is q. All right, let's watch the picture. What's the sign of minus t? The sign of minus t is the y coordinate of q. So sine of minus t is the y coordinate of q. Okay, so I'll keep watching. So that's the sine of minus t. So this value here, this is the sine of minus t. Okay, in your mind, let t be pi over 3. That's the sine. Now, what's the sine of t? Right there. This is the sine of t. So the sine of t is the y coordinate of the point P. Okay, so the sine of t is from here to here. That's the sine of t. It's a positive. The sine of minus t is negative. It's from here to here. Now, if we use the symmetry of the circle, those two are equal in length. One is positive and one is negative. Again, by symmetry of the unit circle. So by symmetry, P and Q are symmetric with each other, are symmetric with respect to the y-axis. Those 2 points are symmetric. From here to here is the same from here to here. It means their y coordinates are the opposite to each other. It means the y coordinate of one is minus the y coordinate of the other. Okay, so this is absolutely a true statement. And that's really the picture. This is sine t, that's the sine of minus t. Sine of t is this y coordinate, sine of minus t is this y coordinate. By symmetry, they are exactly the same. So what does this mean to you? What it means is the following. It means that the sine of minus pi over 3 is minus the sine of pi over 3. That's really what it means. The sine of pi minus pi over 4 is minus the sine of pi over 4. That's really the relationship. No matter what the angle is, the sine of minus t is minus the sine of t. However, for the cosine, that's not what happened. The cosine of minus pi over 3 is equal to the cosine of pi over 3. The cosine of minus pi over 4 is equal to the cosine of pi over 4. So that's the picture for sine, and that's the picture for cosine. So in terms of identities, that's an identity. That's absolutely an identity, but this is false because this does not hold. That's the idea of an identity. All right, I'm going to give you another true and false. Again, I want you to try to think a little bit in terms of the unit circle. So I will give you D in my worksheet. And the question, true or false? Okay. Okay. All right, I'll give you a minute to think through that. True or false? Okay. False, you give me an example. True, you give me an example. Use the unit circle to guide you, if you can. Okay. I'm watching chat very carefully to see what you guys are putting on. Okay, I'm having a lot of false. All right. Okay, more false, then I need examples. False, I'm going to show you on the unit circle why, but those who are giving me false, I need examples from them. All right, so Jacob is giving me false. We have to give example. It means I want to find a value for t such that this is not working. Okay, is Jacob's example, does Jacob's example work? Oh, I meant 4 over pi over 4. All right, that's better than that. Okay, t equal pi over 4. Let's see if this example works. All right, what's the cosine of t? And what's the cosine of pi over 4 plus pi? Okay. All right, are those equal? First, let me watch on the unit circle, and the unit circle will tell me the whole story actually, and tell me immediately whether they are equal or not. Pi over 4 is here, right there, right in the middle. This is pi over 4. So the cosine is right there. As I don't think you guys can see this. I have to write in red. This is pi over 4. Now, when I take pi over 4 plus pi, that's pi over 4, I'm going to add pi to it right there. So this big one is pi over 4 plus pi. So immediately, so this little one here is pi over 4 plus pi is big one. So immediately, the cosine of pi over 4 is positive. The cosine of that is absolutely negative. Then they are absolutely equal, not equal to each other. So even the unit circle tells you if you take t, if t is the first quadrant, its cosine is positive. T plus pi is going to be in the third quadrant, its cosine is going to be negative. They are absolutely not equal to one another. And if you evaluate, the cosine of pi over 4 is the square root of 2 over 2. And so this point here, if you guys remember, the square root of 2 over 2, square root of 2 over 2. This one is minus square root of 2 minus the square root of 2. So this is minus the square root of 2. Absolutely different from one another. So that's really, so that's false because you were able to give me an example where it is false. True, you have to give me an example to have to justify why it's always true. And this is using the unit circle. Okay, let me give you one more, and then we're gonna, keep working with those. True or false? True or false? Back to you. True, justify. False, justify. I'm not getting any answers. What do you think? True or false? Look at the meaning of each expression. False, because Alex, why false?
To me, when you have cosine squared t, it means that you apply cosine squared to the whole equation after it's been used. Whereas cosine t squared, you have to square t first and then apply cosine.
He's absolutely correct. Cosine squared t, it means you're taking the cosine and the whole thing you're squaring. It means you're squaring the cosine. However, cosine of t squared, that's why we have to be very careful with where we put the power. It means you're taking the t squared first, step one. After you take the t squared, you're taking it as cosine. Now, examples will be very easy. So suppose I take t to be, I don't know, suppose t is pi over 4, for example. What's the cosine square of pi over 4? That's the cosine of pi over 4, and that's the cosine that you are squaring. Now, pi over 4 is the square root of 2 over 2. is this what you square? Is you square the whole cosine, which will give me square root of 2 over 2 times the square root of 2 over 2, which this will give me a 4, and this will give me 2, which is a half. However, when I compute cosine of t squared, this means the following. You take the t and you square that, and then you find its cosine. It means basically, which is I have no idea what the answer is going to be. Basically, you take pi over 4 and you square it. It's pi over 4 times pi over 4. It means pi squared over 16. That's really what you do. And then you pick up your calculator. I pick up my calculator because I have no idea, and I want to make sure which mode I'm in. Mode. So I was in radian degree mode. So it means I take the cosine this time of pi square divided by 16, which is going to give me definitely not 1/2. Okay, so we have to be extremely careful with our notation. So this is, you take the cosine, you square it. Here you take the angle, you square the angle, and then you take the cosine of the square. So that's absolutely false properties. All right. Questions as I move on? Okay. Now, let us summarize a little bit what we saw as identities. And so let's see, what did we see as identity? We saw the following. The summary of the identity we saw so far. Summary. Plus sine squared equal to 1. That's an identity because it's always true. Now from this identity, I can deduce the following, that the cosine square is always 1 minus the sine square. I just solved for cosine. From this one, I can deduce that the sine square is 1 minus the cosine square. So all those, I can deduce them from this one. Right? Now, other identity we saw is that the secant square is always 1 plus the tangent square. Those are really the most basic. Now, the other important identity also we saw in those examples is that if you take cosine of minus t, it's the same thing as the cosine of t, totally using the symmetry of the unit circle. And then the sine, it doesn't behave this way. It's minus the sine of t. Okay, so these are the identity that we did. Now I'm going to give you a small examples, not some, it's a way to practice those a little bit more, especially the first three. So my question is going to be the following. I'm going to give you an expression, and my question is going to be simplify the expression below. And I have to give you guidelines so that only one trigonometric function remain. Trigonometric function remain. Means I want you to practice those identities in a way. Okay, so I want you to simplify them. So at the end, I only have one trigonometric function, so not two. So I will start the first one, and then I will somehow give you another one. So suppose I give you the following expression. Cosine squared t minus, let's say minus here, sine square. Okay, the idea is that use those, what I gave you, so that you can express this piece in terms of one trig function only. So what do I mean by that? So here I have two trigs, cosine and sine. I want the answer to involve only one. So what can I do? It's not hard, but just, okay, what do you think I want to do? So this is an expression that involves both sine and cosine. Okay, but I wanted to involve only one of them. What do you think I can do? Make the denominator. There is no denominator, Jacob. What denominator? It's easy now. The denominator comes later. Okay, I'll guide you for this one. I say, okay, I only want one trig function, but I have two. So somehow I need to get rid of one, but I cannot get rid of one. I cannot get rid of anything. So one way I say, all right, if the cosine square, I can express it easily in terms of the sine. So we're going to do substitution. Exactly. We're going to substitute. So I'm going to write here, we're going to substitute cosine square t by its value, 1 minus. That's what we're going to do. So what do we mean by that? I mean, instead of cosine square, I'm going to put 1 minus sine square. So the idea is really to practice those properties. Minus the sine square t. And now this is going to give me 1 minus square minus 2 sine square. And of the problem. That's really what we mean. So there is no denominator here. We only have to substitute the cosine square by its value. All right, the last 3 minutes, I'm going to give you this one. The question is the same. I have an expression that involves the sine and the cosine. And I wanted to express it in terms of cosine in an easy way. Okay, please work it out in front of you, see what you come up with. Okay, we have 2 minutes. We should be able to do it. The answer is cosine of, okay, anybody else got anything close to it? All right. Let me see, any student. I want somebody to lead me, to help me. Asia, what are you working on?
Well, I started by substituting the sine squared t.
Yeah, what did you put?
1 minus cosine squared t.
Okay. So she did exactly what we did before. She substituted 1 minus cosine square for sine square. Very good. And now what do we get? Verbatim. 1 minus 1 minus minus plus cosine square over cosine. So I did verbatim what she said. All right. So the idea is just to use them. Plus 1 minus 1 cancel each other. I will have the cosine square of t over the cosine, which is equal to Now cosine square is cosine t to the power 2. That's really what it means. So now if I simplify cosine t, which means cosine t over the cosine of t, which leaves me with the cosine of t, because now I can simplify. So this seemingly complicated term is really, really nothing more than the cosine of t. Okay. All right, I stop at this stage. Please, I'm gonna put homework on right space. Please do the homework for next time. That's the only way you learn. There is no other way, right? So the class is dismissed. Any student with any questions, please, you can remain and ask.